Hello, my name is Adam. In this video, we are going to recreate the classic arcade game Asteroids in Unity. This is the third video in our series of recreating old arcade games. The first one was Snake, the second one is Pong, and now this third one is going to be Asteroids. Specifically, we are going to focus on a couple things. One is procedural generation. So how can we generate our asteroids or spawn our asteroids in a unique and interesting way, but do so completely programmatically, right? How can we randomize different properties of our asteroids so they all feel unique and everything feels natural, and it creates this good sense of gameplay and all these asteroids come flying at you at the player. And the second thing we're going to focus on, of course, is the shooting mechanics. Right, so as the player, as you fly around, you'll want to be able to continuously shoot at the asteroids to defend yourself, and this will be a big part of our game. And we want to do this completely through Unity's physics engine. So we'll learn how to do all of that today in our video. Let's go ahead and dive in. Let's begin by creating a new project using the Unity Hub. We can click the little drop-down menu in the top right here in this blue button. And this will allow us to select the specific version of Unity we want to use. So for this tutorial, I'm going to use 2020.2.1. It shouldn't actually matter too much which version you are using, but if you want to follow along exactly, I would try to use pretty much the same version as this. Go ahead and name this project whatever you like, Asteroids for example. Choose wherever you'd like to save it. And let's make sure we're selecting the 2D template since this is going to be a 2D game. Go ahead and click create, and you might need to wait for this to finish loading. It could take a few minutes to initialize. Once your project is initialized, Unity will provide you a sample scene by default. So we can actually go to our scenes folder here, and I'm going to actually just rename this to Asteroids. And this will trigger us to reload. And by default, this scene just has one game object, which is our camera essentially. So first, we want to set up our entire scene. We're going to create a number of game objects and then add some components to those game objects before we begin to do any scripting. So since the camera already exists, we'll just start with our camera. And the only thing I want to change is this background color. I'm just going to make this black. You can see a preview of our camera here. And we can also switch over to our game view here to get the full preview. Let me go ahead and change my resolution here. Let's do 16:9. Feels pretty good. Feel free to adjust your window to your preferences. And so there we go. There's our camera with our black background. There's nothing else we need to change for our camera. Next, let's create some boundary walls that will surround our camera's view. This is going to prevent the player from being able to navigate past the edge of the screen here. If we go to our scene view, you can see this white outline, which is indicating exactly the edge of our camera. So essentially that's going to be the edge of our screen. So we can right click in our hierarchy here and we can choose create empty. And let's just call this boundary. And let me reset the transform here by selecting the three-dot menu, choosing reset. That just sets all the values back to their defaults. And there's one component I want to add to this, which is a box collider 2D. Of course, we're going to use the 2D versions of all these components since this is a 2D game. You can see this little green outline is indicating our box collider. And a box collider is defining the shape of the collision area. So let's go ahead and position this at the very edge of our screen. Let's make sure it lines up exactly. So let's say 5.5. Now we can scale it in the x-axis. Let's just make that something like 18. That looks good. It doesn't, in this case, it doesn't have to line up perfectly as long as that main edge is lined up. We can duplicate this by right-clicking it and selecting duplicate. Now we can flip this from positive to negative, and now we have our bottom one. Let's go ahead and duplicate this again. And let's create our left and right. Now in this case, we want to flip the axis that this is being scaled on. So instead of the X, we want to scale in the Y. And I think the scale here will be scale of 10. That looks good. And let's position this all the way on this edge. Negative 9.4 lines it up perfectly. Good. Let's duplicate this one and let's flip it from negative to positive, and there we go. So there's all 4 of our boundary walls directly on the edge of our screen, which is going to prevent our player from being able to navigate past the edge there. And let me just rename these all to boundary. Okay, good. That's it for our boundaries. Finally, we can create our player sprite. So let's go ahead and add one more game object to our scene here. So we can right click, we'll do create empty again, and we'll call this one player. Let's reset the transform as well. And there's a few components we need to add. So for one, we need a sprite renderer. And the sprite here we can assign. I'm going to pull in a sprite that I've already created. All of the assets I'm using, the sprites and so on, will be available to download for free. There's a link in the description that will take you to the GitHub project for everything here, which has all the assets and everything that you can use. But also feel free to create your own sprite if you would prefer that too. So let me go ahead and drag this in, player. There's my player sprite that I created. And also I'm going to organize my files here. So I'm going to create a new folder for sprites, and let's go ahead and move that to that folder. And so now that we have the sprite added here, I can drag this into this property here, and there is our sprite. And you can see in our game view, we can actually see our player showing up, which is perfect. Now there's a couple other components we need to add to this game object. So another one we want to add is called a rigid body. And then of course the 2D version. A rigid body is going to turn this object into a physics object. So you can see there are a number of physics related properties like mass, drag, gravity, etc. Because of this component, the physics engine will actually simulate, physics on this object. And then finally, we also need a box collider 2D. Once again, the box collider is defining the shape of the collision area, which is outlined with this green rectangle here, which is just going to fit around our player. Some of these properties on our rigid body we will change later on once we start scripting our player movement, but I'll wait to change those so I can properly explain them then. But that's actually it for our scene setup. There's nothing else we need to add at the moment. Next, let's start scripting our player movement. Let's go ahead and create a new script. I'm going to also create a new folder to contain all of my scripts. So let's call this scripts, and let's open this up, and let's right click, create C# script, and I'm going to call this player. And once we have a script, we can add that script to whatever game object we'd want. So of course, we're going to add this to our player game object. We can drag this into the empty space, and now we can have the script show up. This means that when this game object is active, the script will also be running so long as it is enabled. Let's click our 3-dot menu. You can do edit script. You can also double click on the script itself. And let's go ahead and start adding some code here. Unity by default creates a class that inherits from mono behavior. They also provide a couple of functions here that are just very commonly used. But I actually like to just kind of delete everything and start from scratch personally. It's just my preference. So for our player movement, we first need to check for input. And then based on that input, we will call some functions on our rigid body. So to check for input, we can do that inside of a function called update, which is a function that Unity calls for us automatically every single frame our game is running. And this is very commonly used, or it's very common that you do input inside of this function. So we can say, for example, if input.getKey, and then there's a few variations here: get key down, get key up. Get key is going to return true or false every single frame a given key is pressed. And then get key down, get key up will return true just for the single frame that key was either pressed down or pressed up. So it just is like it's just kind of, did you press it once versus are you continuously pressing it, which is get key. So for moving, we want to say, are you continuously pressing, some key here? So let's say, for example, for moving forward, we can use W. So I'm going to use W, A, S, and D. And we could also use arrow keys too. So we could say or input.get key code dot up arrow, right? And then if that's true, we will do something. Now in this case, we actually we're going to check for inputs separately from actually moving our player. And I'll explain why once we get there. But for now, we just need some variables to know the state of our movement. So I'm going to have a Boolean here called thrusting. All right, so Boolean is just going to be true or false. You're either thrusting or you're not thrusting. And so instead of doing the if here, I can say thrusting equals, you're pressing the key, you're pressing your W key, or you're pressing your up arrow, right? And then I can have another one for turning. But in turning, it's not just true or false. It's, I need to know, are you turning left? Are you turning right? Or you're not turning at all. So I'm going to actually use a float here. I'm going to call this turn direction. And so for this, I can say if, you know, and then same thing here, although we're going to change the keys. Let's say for left, we'll use A and then left arrow. So if you're turning left, we're going to say our turn direction equals. So intuitively, you would think negative would be left and positive would be right, which in most cases is correct. However, the way we're going to actually rotate our player is going to be sort of the inverse, because we're going to be applying torque to our rigid body to rotate the player. And it's going to be kind of the inverse of what you would normally expect. So we're actually going to have turning left is actually positive. And for turning right here, it will be the opposite. So for right, we're going to use D and then right arrow. And turn direction will be -1 this time. And then if none of those are true, then we can just say turning is 0. Turn direction is 0. So that's checking input. Now for actually moving our player, we're going to do that in a different function called fixed update. And the difference between these is that fixed update gets called on a fixed time interval, whereas update gets called every single frame the game is running. So usually for physics related code, you do it inside of fixed update, because if physics was ran during update, that means it would be variable or dependent upon the frame rate of your game, which is going to lead to very inconsistent physics. And so fixed update, since it runs on a fixed time interval, it's going to make sure that the physics is consistent. And so here is where we'll actually do some stuff on our rigid body, but we actually don't have a reference to our rigid body, so we can't do anything yet. So we need to establish our reference to our rigid body. So I'm going to create a new variable called rigid body. It's going to be of the type rigid body 2D. And the way I can grab a reference to this object is in the awake function. So awake is going to get called one time for the life cycle of the script. And it's very commonly used to do initialization type work, or maybe, you know, establishing references, for example, which is what I'm going to do here. So rigid body equals get component, and then the type of component want to get, which is our box collider, or not box collider, my bad, rigid body 2D. Okay. So this is once again a function that Unity provides for us that allows you to get a component. It's going to search for a component on the same game object that this player script is attached to. So in our scene here, that is our player. You can see our player game object. Our player script is attached here. So it's going to look on this same game object and find the component that we specified, which is rigid body 2D. And so now that we have a reference to our rigid body, we can actually go ahead and call some functions on this. So we can say if you're thrusting, well, then we can say rigid body add force. So by adding a force, it's going to move this object via the physics engine. So add force. and we can add a force. We always want to thrust forward. You can only thrust forward. And so the way we represent forward, always know the forward direction of our player ship is by just saying this, so transform that up. If this was a 3D game, you usually would say this, transform that forward. But for a 2D game, you would just say dot up, so this is kind of the equivalent there. And then we can also multiply this by some kind of scalar, which would be like a speed, right? So we might want to have a variable here for thrust speed. And by default, I'll just set that to 1. Right, and now we can multiply this by speed. And I'm making this public because now it'll actually show up in our editor here. You can see it shows up there. Thrust speed is now 1. And now for rotation, it's going to be somewhat similar. But in this case, since it's not a Boolean, we need to say if turn direction does not equal 0. So as long as it's not 0, that means we are turning in some direction. And instead of adding a force, I'm going to add torque. And the torque is going to rotate our object via the physics engine. And so for torque here, I just need to provide a float. And this is just going to be our turn direction. And this same thing here, we can also multiply this by some kind of speed. So we can have a different variable for our turn speed. Turn speed. Let's say defaults to 1 as well. This dot turn speed. And there we go. So that's it. That's checking input. And then based on the state of that, we can apply physics to our object here. Let's go ahead and actually test this out and maybe play around with some of our variables here. So let's go ahead and run this. And notice how I just immediately fell to the ground, and that's because I have gravity turned on. So I actually want to turn off gravity, set that to 0. And now our object will not just instantly fall over. Here I'm turning way too fast though, and that's because we have very little drag. We want to bump our drag up to, let's say, 1. And this is going to make it so the drag is going to allow me to actually slow down and decelerate. And angular drag is for rotation and linear drag will be for our movement. So also notice here, if I move forward, I don't ever stop. I'm not pressing my keyboard anymore. It's just still moving. It's because we have no drag. So we probably also want to set that to something like 1. And that feels a little bit better. I'm still turning pretty fast. And so we can also tweak our variables here. So we can say turn speed, let's say is 0.1. And that feels a lot better. Yeah, that feels pretty good. Overall, it's good. I think overall though, I feel very heavy. My ship feels very, very heavy, which maybe isn't a bad thing, but in this case, I might want to reduce my mass, let's say to 0.5 and see how that feels. Yeah, that feels a little bit better. I feel like I can move fairly quickly. I can turn fairly quickly. It's responsive, but also it still has some of that floaty feel that makes sense for moving a ship in space, right? If it still takes some time for my ship to actually decelerate and come to a stop, and I can still sort of float around, which feels appropriate for this kind of game. So there, that's good. These feel like good values here. Now, one problem is that I tweaked these values while I was playing the game. And so when I stop this, all those values then get reset. So that's just something to keep in mind, that if you want to save those values, you got to make sure you do it when you're not running it. Let me go ahead and set these all back. So drag 1, gravity 0. And then I changed my turn speed to 0.1. Oh, I also changed my mass to 0.5. There we go. All those values are back to how they were. But there we go. That feels good. Player movement is done. Next, let's start handling the shooting mechanics of the game. So let's go ahead and first create a bullet. So we can right click on our hierarchy. Let's go down to 2D object, sprites, and select square. And let's call this bullet. So this is going to create a game object with already a sprite renderer on it, and it's already going to have a square sprite assigned. And you can see our bullet show up there. It's a little too big though, so let's go ahead and change our scale here. Let's set the scale to maybe 0.075. That feels pretty good. Feel free to play around with the scale based on your preferences, but it feels pretty good to me. We're also going to want to add a rigid body to this game object as well. And of course, we're going to need a box collider as well, so we can know when collisions are happening. For our rigid body though, we want to change some of these properties. As we saw when we were doing our player movement, some of these properties might not make sense, such as gravity we want to turn off. And for our bullets, we don't really need to worry about drag or anything. We don't care about rotation at all. So we can just get rid of drag, and we can even freeze the rotation just to make sure our bullets aren't like spinning out of control. They just want to move straight. We don't necessarily care about them rotating, at least not by the physics engine. Now for drag though, drag actually is important. It's important it is set to 0. If it's not set to 0, then our bullet will actually come to a stop, which won't make sense. Once you fire the bullet, it should just keep projecting in its direction. It should never come to a stop due to physics or friction or whatever, right? So we should make sure that's set to 0, which it already is, so we're good there. So that's our bullet, and we want to turn this into something called a prefab, which is a custom asset that you can create. So in our project panel down here, we'll go ahead and create a new folder, and I'm going to call this prefabs. And all we need to do is take our bullet here and drag it into this space. And now we have a prefab, and it even says bullet.prefab. So a prefab is going to allow us to we can reference this prefab in one of our scripts, and we can clone that prefab over and over again every time you shoot. And now that we actually have this asset down here, we actually don't need this in our scene anymore, right? So notice how I deleted it from the scene, but the asset still exists. And that's what the great thing about prefabs is they are a custom type of asset that will persist across your entire project, and you can reuse them in various ways. So let's go ahead and create our bullet script next. Let's go to scripts, and let's go ahead and create a new one, C# script. I want to call this bullet. And let's first, before we do anything, let's add that script to our prefab. So we can just go ahead and drag that over to the empty space, and now our bullet shows up. Let's go ahead and start editing this. And so for our bullet, we're going to need to project it along a certain direction by adding a force to our rigid body. So just like we did for our player, we need to get a reference to our rigid body. Let's go ahead and add that variable there. And then in our awake function, once again, just like we did for our player, we can establish that. So rigid body equals get component, rigid body 2D. And now for our bullet, we need to project it along in a certain direction. And it's really going to be the player that determines the direction, right? So based on the rotation of the player, the bullet will project in that whatever that forward rotation is. But the bullet doesn't have that information. The bullet script here doesn't know anything about the player. And so the player, since it's the player who's going to check for input, which will then shoot, cause the player to shoot, which is going to spawn a bullet. The player will actually inform the bullet which way to project itself. And so we're going to create a public function here. That way the player can actually call this function. We're going to call this project, and it's going to pass in a direction here. Direction. Right, and then given that direction, we can say rigid body add force, and we'll add a force in that direction. And once again, we can multiply this by some kind of speed. So let's add a variable for speed. And our bullets here are going to need a really fast speed. So let's give it a value of 500. And once again, we're going to make this public, so we can always tweak that number in the editor based on our preferences. But for a default, 500 should work well. This dot speed, so multiply the direction by speed, and there's our force. One other thing we might want to do is give these bullets a lifetime, like a maximum lifetime. That way they're not persisting forever. They'll eventually get destroyed. So we can have a variable here for max lifetime. Let's just say they will at most last 10 seconds, right? So in seconds there. And so when the bullet is projected, we can say destroy this.game object, and then we can pass in a delay here, so which is our lifetime. So as soon as the bullet is fired, basically, it's going to add the force to start moving it, and then it's also going to say, okay, destroy this bullet after, you know, whatever the lifetime is set to, 10 seconds, for example. And this is just going to ensure the bullet eventually gets destroyed. It doesn't just move on forever, you know. And that should be it for our bullet. From here, though, in our player script, we need to actually instantiate that bullet. And so we can add a variable for our bullet here. And actually, we're going to reference this as, we're going to reference our prefab, that asset we created previously. That's what we're going to assign here. And that's what we can instantiate. But we specifically want to pull out the bullet script that we just added so we can call this function. So we have our bullet prefab there. And let's go ahead and add a function called shoot. So every time the player shoots, we will instantiate a new bullet. And we can do that by saying instantiate, and then we can pass in an object that we want to clone, which is our prefab. And then we need to give this, we don't have to give this, but in this case, in our case, we want to. We need to give it a position and a rotation. So the bullet should always spawn at the same position as the player. So we can say this.transform.position is referring to the player's position. And then same thing for the rotation. We want the bullet to be rotated in the same orientation that the player is. So this.transform.rotation is once again referring to the player. And then once we have a reference to our bullet, we can say project. And we will project this in the direction that our player is facing. And we already know what that information is because we did it when we were thrusting, right? When we were thrusting, you can only thrust in the forward direction, which is this value here, this.transform.up. So we're going to use that same thing when we project our bullet. Great, so that's it. Now we actually need to call shoot somewhere though. It's not being called anywhere. And we're going to call it an update after we check for input. So we can say if input.get key down. In this case, I want to use get key down, not get key. I don't want to shoot every single frame you're pressing the key. I want you to have to fully press the key, and then it'll shoot that one time you press it, and then you'll have to press it again in order to shoot again. Now that is preference. So if you want to be able to hold it down, that's fine. You can use get key, but in my case, I'm going to use get key down. Now I'm going to say spacebar to shoot, or maybe I also want to shoot with the mouse button. So I can say get mouse button down. Then I can pass in an index of which mouse button, which for the left click is just 0. And so given that input, I will shoot. Great. So there we go. So let's go ahead and test this out. We've got our bullet script. And we've got our player script modified here so we can actually instantiate new bullets. Wait for this to compile. It's taking a little bit longer than normal. Okay, so let's go ahead and make sure everything's good here. So for our player script here, we need to establish this reference to the prefab. Let's go ahead and drag in our prefab over there. That way it instantiates the correct thing, the correct object. Let's go ahead and run this and see what happens. So let's press space. So I'm pressing space. Now it's rotating me, which is kind of weird. And that's because the bullets are colliding with me, which is not what I want. And so we can actually change that by updating our project settings. So edit project settings. You should get some kind of window. You can always bring this wherever you'd like. I'm going to drag it over there. Let's go to physics 2D. And at the bottom, you can see this collision matrix, which allows you to choose which physics layers collide with one another. Now we don't have physics layers to represent our player and our bullets. So let's first add those. So let's go to our player, for example. There's this layer property up here. And we can add a new layer, and I'll call this one player. And let me add another one for our bullet as well. So for our player, we're going to select player. And for our bullet, we are going to, once again, our bullet prefab, we're going to select bullet. And now if we go back to that collision matrix, we can say, okay, when the player bullet collides with another, we don't want that to happen. And we do not want the player and the bullet to be able to collide with one another. We probably also don't want bullet to collide with one another. And while we're at it, let's make sure the player can't collide with itself. Although I don't think that, I guess that's not really relevant because there's only one player. So, but regardless, we don't want those kind of collisions to happen. Let's test this one more time. So there we go. Now I can shoot. That feels a lot better. Notice how our bullets aren't getting destroyed. They're hitting those boundary walls, which is good. But they're not getting destroyed. Oh, and you can actually see they're starting to disappear, and that's because of that max lifetime. But we do need to have these objects get destroyed as soon as they collide with something. So let's go ahead and edit our script one more time. Let's go to our bullet script, and what we can do is add a function called on collision enter 2D. There's one parameter here, which is collision 2D. We'll just call this collision. And so this is a function Unity is going to call for us automatically anytime our bullet collides with something else. And this is possible because we've added those rigid body and collider components to this object. Without those components, this isn't going to get called. All right, so in collision enter, we just need to destroy the bullet. And it doesn't really matter what you're colliding with. So sometimes you might want to check that you're colliding with a particular type of object. In our case, if the bullet collides with anything, it's going to get destroyed. So we can just say destroy this .game object. Same thing we did here, although we don't need that delay. It's just going to get destroyed immediately once it collides with something. Let's go ahead and test that one more time. This time when I shoot, yeah, we should... It looks like they're just traveling past the screen, but really they're actually just getting destroyed right away, which is perfect. They don't need to traverse past the screen. So there we go. There's player shooting. So now we can move around, we can shoot, and next up we'll need to start adding our asteroids. All right, for our asteroids, it's going to be one of the more complicated pieces of this tutorial. But first, let's start simple with something we're already familiar with, which is creating a prefab for our asteroid. So we just did the same thing essentially for our bullet. Let's go ahead and do that for our asteroid. So let's create a new game object. Let's right click on our hierarchy, choose create empty. We're going to call this asteroid. Let's go ahead and add a few components. Same thing we did for our bullet, which is sprite renderer. And then we're going to need a rigid body and a box collider. But first, let me assign the sprite here. And I'm going to drag in a few sprites that I already have pre-created. 1, 2, 3, and 4. So I have 4 variations of this, actually. That way, each asteroid feels somewhat unique compared to the others. But once again, all of these sprites will be available to download completely free with the rest of the project through GitHub. There's a link in the description of the video. But also, once again, feel free to create your own if that would be your preference. So for our asteroid, we're going to just give the first one as the default, but later on, programmatically, we will choose a random sprite to assign to our asteroid. But initially, we'll just give it one. Okay, let's add our rigid body 2D as well. And properties here, kind of the same thing we did for some of the others, where we don't need drag or anything or gravity. Mass, so we're going to actually change the mass of the asteroids programmatically. We're going to kind of pick a random size for the asteroids and then give them, set the mass dependent on that size. But that should be good for that. We probably don't want our asteroids to rotate either. We don't want them to start spinning around, so I might want to freeze their rotation. Constraints freeze rotation. And that should be good for now. We can always add or tweak more later. And let's add our box collider as well. And there we go. There is our sprite. And if I change this to 1, yeah, I'm going to set this to 1 only because we're going to be changing the sprite dynamically and the size and everything. And I don't... The 1 is a little bit more consistent because it might slightly vary depending on the sprite here. So I'm just going to set that to 1 as a default. Okay, let's see what else. So that's our asteroid. Now we can turn that into a prefab by dragging this into our project panel, just like we did for our bullet. And there's our asteroid prefab. Great. And then we can delete it from our scene. We have the asset here. And let's start by adding our asteroid script. And we eventually will need to add an asteroid spawner. So that'll be a separate script, but let's just give our basic asteroid some properties here. So select our prefab. Let's bring our script onto it. Good. And let's go ahead and start editing this. So what we want to do is kind of give it some random, some random properties when this first starts. So in our start function here, let's randomize a few things. So let's randomize, for example, its size and its rotation and its sprite. And so for all of those things, we're going to need a couple references to some other components. So we're going to need a reference to the sprite renderer on the asteroid, so we can change which sprite is rendering. We're also going to need a reference to its rigid body as well. And so just like we've done for some of our other scripts, we can establish those references in our awake function. And we can say sprite render equals get component sprite renderer. And let's fix that. And rigid body get component rigid body. Oh, and this was a mistake. These should be 2D. There we go. Okay, so on start, we can say sprite renderer dot sprite equals, and we can then pick a random sprite from our for. So we can add a variable here that is an array of sprites. So we have an array of sprites here that we can assign in the editor, and we can pick a random one from this array. And to do that, we can say random.range between 0 and then the amount of sprites we have. So sprites.length. So this is just going to pick a random one of those sprites. Let's rotate, or let's randomize our rotation. So we can say this.transform.Euler angles equals a new vector 3. And we want to rotate on the z-axis. So x and y can be set to 0. And our z will become, we can say random.value to generate a random number between 0 and 1. And then if we multiply that by 360 degrees, there we have a random rotation. And that's not going to, later on when we spawn our asteroids, we're going to give them a random trajectory, which is also going to be based upon essentially a rotation. This here is more so just for kind of the visual. It's more of a visual thing, right? Just so the sprites themselves, it'll pick a random sprite. And it's also going to rotate the sprite essentially so they don't all look the same, right? We want to try to make them all feel somewhat unique. And then another way we can do that is by randomizing its scale as well. So some will be big, some will be small. So new vector 3 here. Well, actually, so for the scale 2, the scale or the size is going to have a bigger impact. The size is not going to only change the visual size of it, but it's also going to change some of the physical properties too. It's going to change the mass of the object, which actually is going to change how the physics is simulated. And also later on, when you start shooting the asteroids, they can actually split into smaller asteroids, right? So if there's a big enough asteroid, it will split into smaller ones before they eventually get completely destroyed. So that's all going to be dictated by the size of our asteroid. So we should probably have a variable here for size. And initially, let's say it has 1, but this is going to get randomized when we spawn them. So later on, we'll have a different script for spawning the asteroids, and we'll randomize the size between some range. So I guess we will need some, we'll add those properties now for the range. So min size, let's say is, you know, I don't know, 0.5, and max size is, let's say 1.5. We can always tweak those later in the editor if we need to. So yeah, these two we won't use yet, but they'll come into play later. So here now for our scale, we can just say we want this to be scaled by whatever that size is. So this will get assigned elsewhere. So at the point in time that our script starts, this will already get a random value. So here we're just going to take that size and apply it to our scale. And I'm saying 1 times our size, which is just a shorthand way of saying this. It would be a shorthand way of saying this dot size, this dot size, this dot size. So it's just a little bit simpler way of writing this line of code here, which is just giving, you know, creating a vector with whatever our size here is in all 3 axes. Okay, so that's our local scale. We also want to set the mass of our rigid body to be whatever that size is too, right? So the larger the size, the larger the mass. And is there anything else we want to do? So random sprite, random rotation, random scale, random mass. I think that's probably good enough for now in order to make each asteroid feel a little bit unique compared to the others. And there'll be some further randomization we do when we spawn the asteroids, such as the trajectory that they travel on, where they exactly spawn, right? So there'll be even more randomization to kind of make everything feel a little bit more natural. But for now, this is good for our asteroid. Okay, so let's create our asteroid spawner. Right click, create C# script. Asteroid spawner. This is going to be one of the more complicated pieces of code we write. There's going to be a few different things happening here. So for our spawner, we want to spawn asteroids at a regular rate. Yeah, we want to spawn a new asteroid at a regular rate. And so one way we can do that is use a function called invoke repeating, which is just going to invoke a method every X amount of seconds. And it's going to, you know, it's just going to repeat that method call over and over again. And we want to do that as soon as the spawner starts, then we will invoke this. Now, what's the function we want to invoke? Well, let's just have a function called spawn. All right, so we'll invoke spawn here. This is, you have to reference that method by its name, so we can say name of, then the name of that method, which is spawn. And then we need to provide what's the initial time to call this, and then from after that, how often do you want to repeat it. And so we need a variable for that, and we can call this spawn rate, and maybe it's every 1 second. Maybe every 2 seconds. 1 second might seem pretty quick. So every 2 seconds we'll spawn some asteroids. And once again, this is public variable. We can always change that in the editor if we want to tweak the gameplay. And so we're going to use this spawn rate for both of those arguments there. So what we just did is basically this spawn method is going to get called repeatedly every 2 seconds. That's essentially all we did there. And so within our spawn here, we can create an asteroid. Now, maybe we don't want to create just a single asteroid. Maybe we can make a variable for that as well. And we can say spawn amount. All right, maybe by default it spawns 1, but maybe you want to say, hey, I want to spawn 10 asteroids every 2 seconds. That would be quite a lot, but let's create the variable so we can play around with that later. So here we can establish a simple for loop. I is less than whatever the spawn amount is, I++. And now in here, we can do all of our logic for spawning each asteroid. So to actually spawn an asteroid, we're going to need a reference to a prefab, just like we did for our bullet. So let's call this Asteroid Prefab. All right, so if you remember in our player script, we had a bullet prefab where we referenced the bullet script, and then we can instantiate it. This is going to look very similar. So Asteroid Prefab. So here we can spawn a new asteroid by saying instantiate, and we're going to copy the prefab. And we need to give this a position and a rotation. Now these are going to be some of those other randomizations we do. So we need to spawn the asteroid at a random position and give it the rotation. Is going to then also determine its trajectory. So we'll give it a random rotation 2. So let's just handle each of these separately. Let's start with our spawn point. So we're going to need our spawn point. We'll call it a spawn point. And that's actually going to become that. So for spawn point, let's actually go to our editor real quick. So we're going to have, let me create a new object here. Let's create an empty object and we're going to call this spawner. Let's reset its position all the way back to, reset the whole transform to 0. And let's add our script to that. And so our spawner here is going to be an object in the scene that we can change the position of. If we want to, we can choose where to spawn these enemies by moving this spawner somewhere else. And we could even have multiple spawners if we wanted to. And let's say when we have a spawner, it's going to spawn asteroids in a radius around that spawner. Okay. So in a random radius, and then some distance away from that spawn, from the position there. So so whatever distance you want, and then it should make sure it should be relative to the position of the spawner. So there's a few different things that are happening here. So first we need to get a random kind of direction, like radial. We need a kind of random radial direction here. So we can say spawn direction, and one way we can do this is saying random dot inside unit circle. All right, this is going to generate a random point inside or on a circle. And in our case, we wanted to always spawn the asteroids on the edge of the circle, never inside the circle, always on the edge. And so if we actually just normalize this, it's going to set the magnitude to be 1, which is always going to be the edge of the circle, which is what we want. Now, if we also multiply that by some distance, we can spawn some distance away from the spawn point. But we need a variable for that. So let's go ahead and add a variable for our spawn distance. So let's say spawn distance. And for our game, we want to make sure we're spawning the asteroids on the outside of the screen. And then they're gonna have their trajectory set to go to the inside. They're gonna spawn the outside, and then they're gonna move to the inside. So to get them to spawn on the outside from the origin here, I'm just gonna keep my spawner at the origin for simplicity. Once again, though, you could have multiple spawners and you can position them wherever you'd want. But for simplicity, I'm gonna have one spawner in the center. And then given that I need the distance here to be large enough that they always spawn on the outside. And I know that the edge to one of these boundaries is about -10. And so maybe I want to increase that a little bit more. Let's say to -15. Not -15, but just 15. To make sure that they're always spawning on the outside there. All right, so we take our direction in our circle and then multiply that by a distance. And that will randomly spawn them in some circle and then however far away from that point. Now the thing is, this is not yet relative to our spawner position. Right now, without making any other changes, they would always be relative to the origin. Which in our case works because our spawner is at the origin. But if I were to move this, it would still be relative to the origin, not to our spawner. So the way we do this is we need to factor in, or we need to offset our spawn point by the position of our spawner itself. Now for the actual spawn point first though, our spawn point is going to be, let's see here, do this spawn direction. I'm drawing a blank here. What is this supposed to be? Our spawn point is our spawn direction, or this should just be this dot transform dot position, which is our spawner's position, plus then our spawn direction. Yep, so our direction once again is kind of picking a random point on the edge of a circle, and then we multiply that by some distance away, and then here we kind of offset that by whatever the position of our spawner is to make it relative to our spawner's position. So that's our spawn point, which is good. Now for our rotation, it's going to be a little bit different. So rotations we usually represent with quaternions. So we're going to have our rotation here. And for our rotation, we need to pick, well, also too, this rotation is going to have somewhat of an impact on the trajectory of our asteroid. So given that they're always going to spawn on the outside, we want them to go towards the inside. All right, towards the center, really. But it shouldn't go exactly towards the center. There should be some amount of variance between there. So we could have a variable for that variance, which is essentially going to be an angle that it'll pick from. So if it spawns out here, it goes towards the inside, it might go, you know, in some cone, within some random cone to determine its exact direction and orientation. So we can say, before we set the rotation here, we can get a random variance here, and we can say random dot range between, well, we need the variable first. So let's say we have a float here for trajectory variance. And let's say maybe it has a variance of like 15 degrees. And 15 degrees might not seem like a lot, but remember they're going to be spawning way out here. So 15 degrees from out here is actually going to cover a pretty wide range of points along our actual screen area here, or our play area. But once again, this is a variable that we can always modify in the editor as needed. So we have our trajectory variance, and this just can be between a negative and a positive of that value there. Okay, and so given that essentially that angle, this is basically an angle, we can create our rotation here. We can say quaternion.angle axis. So this is going to create a rotangle with a given angle in a specific axis. The angle is that variance. And the axis should be our z-axis, which is, if you remember when we rotated our asteroid here, we used the z-axis, same thing. So one shorthand way of getting our z-axis is by saying vector3.forward. You can see vector3.forward is a vector3 with 0 in the x, 0 in the y, and 1 in the z-axis. So that's what that's how you would write that. So create a rotation of this angle in this axis, which is our z. Okay, so there's our random spawn point, random rotation. We then instantiate our asteroid, and there's a couple more things we need to do, and then we can test this out. One is we need to set that random size that we established earlier, right? So we want to actually randomize that. So we can say asteroid dot size equals random dot range, and we created those variables earlier, but now we can actually use them: asteroid min size and asteroid max size. And let's see, Oh, the other thing we want to do is actually start to move our asteroid along the right trajectory. So let's say our asteroid has a function here, a public function called set trajectory. Think of this just like we did for our bullet. Our bullet had a function called project, and the player is the one who calls this and provides the direction. In this case, we're going to have a trajectory, and we can say our direction here. The spawner is the one who will actually set the trajectory, and we'll call this function. And so we can say here asteroid.set trajectory, and the direction should be the rotation multiplied by the direction that it spawned in. Although it should be the opposite direction that it spawned in, because let's say it spawned going towards the top left, right? Once again, it picks a random point in a circle. Let's say it was towards the top left. Well, that's pointing out, right? We want it to always point inward. So if we negate that direction, it's going to give us the opposite, which would always point it in the right direction. And yeah, we need to multiply that by our rotation, so it's all lined up correctly. Let's see. I think that's good there. We do still need to add this code here. So this code here is pretty simple though. This is this rigid body, add force. We're going to add a force in a direction and multiply this by some kind of speed, just like we did for our bullet. We don't have a speed variable yet, so let's go ahead and add that speed. And let's see, the speed of our asteroids, if our bullets are, let's say 500, maybe our asteroids are 50, right? Our 10th the speed. We want the bullets to be fast and the asteroids to be slow, so let's say that's 50. And if we really wanted, we could make this random as well. But there's already quite a few different random things. I don't think we need to. Specifically the mass, because we're changing the mass, and well, we're randomizing the size, which then becomes the mass. The mass is going to determine how fast or slow that object is moving. So we actually don't really need to randomize the speed itself, since we're already randomizing the mass. But we still want to factor in our speed there. And we should probably do the same thing we did for our bullet, where it will destroy itself after so much amount of time, right? So destroy this game object, and let's create a variable for our lifetime, max lifetime. Now for this, it should probably be larger than our bullet. Our bullet was 10 seconds, but our bullet's moving really fast, and so 10 seconds, it can traverse quite a lot of distance in 10 seconds. Since our asteroids are slower, let's make that a longer time to make sure it has enough time to go from one side of the screen all the way to the other side of the screen. 30 seconds should be good, but we can always tweak that in the editor if we need to. And so we'll destroy this after that lifetime. All right. I think that might be it. Should we test this out? Let's go ahead and test it out. We have our spawner here. We need to drag in our prefab reference. Let's drag that in. And let's see. Let's just go ahead and run it and see what happens. Oh, so one problem here. Index was outside the bounds of the array, and that's because I forgot to give my 4 sprites here. So 4 sprites. Let's go ahead and drag all of those in. 1, 2, 3, and 4. And if we go to our scene view, we can actually see these. Now they're moving way too fast. That's for one thing. So they're moving too fast, and they're also colliding with our bounds. So let's fix these problems one at a time. So first, for colliding with the bounds, we can basically do the same thing we did with our player and our bullet by adding layers. So let's go ahead and add that. Let's go to our asteroid. Let's go ahead and add a new layer for asteroid. And then we need a layer for our boundary as well. So for our 4 boundaries, we'll set these to be boundaries. So I just selected all 4, change the layer. I'm going to select our asset prefab here and set that to be asteroid. Now we can go to edit, project settings, go to physics 2D, and we can change our collision matrix here. So let's say asteroids and boundaries will not collide with one another. Asteroids should not collide with other asteroids. So I know that's not realistic. Normally speaking, your asteroids would collide with other asteroids, but for the purposes of the gameplay, I think it'll make sense. It'll work better for the asteroids not to collide with one another. Otherwise, their trajectories are all going to get messed up. And what's going to happen is they're going to start to just kind of cluster around in the middle, and they're not going to actually like fully like traverse through the screen. So for gameplay reasons, we're gonna have the asteroids not collide with one another. But you know, if you prefer it to not be that way, then you know you can always change that yourself. And then boundaries, I guess while we're here, might as well just turn off boundary collision. All right, so let's test again. Let's see what happens. So that's one, that was good. There we go. So they're still moving way too quickly. That's one thing. But it is working fairly well. The spawn distance is maybe too far, so I might want to decrease that a little bit. Oh, the issue too is my spawner is way out here, so that was a mistake. So I needed to reset that back to 0. So maybe the distance was actually completely fine. Yeah, the distance feels good. They're just moving too fast, that's all. They're crashing into my player ship, which is fine. Later on, we'll actually handle making sure the, you know, if you hit an asteroid, you lose. So we'll have to account for that later. But these are moving way too quickly. So why is that? Why are these moving so quickly? It could be mass. It could be other problems. We might want to just change our mass to be larger so they move slower. Let's try doing that. So instead of just directly setting our mass to be this size, let's maybe multiply this by 2. Always multiply it by 2, and maybe that'll slow them down as a whole. We also do have, so that helped a little bit, but we also have a variable for this, right? We have on our asteroids, we have the speed here, and maybe this is just, you know, slower. Maybe this is 10 or so. And let's see what happens. Okay, that's a little bit too slow. It might be a little bit too slow. Let's go ahead and keep the mass how it was. And I think we can just play around with the speed variable until it feels right. Yeah, that feels a lot more appropriate. It's fast, but they're not all going to be that fast, right? So some of them are pretty slow. The small ones tend to be faster because they're lighter. They have less mass, and so they tend to move a little bit faster. And we can maybe even reduce the speed a little bit. I think 5 might work out a little bit better. Yeah, like that feels a little bit more appropriate to me, especially these large ones. These are really large asteroids with really big mass, and so they're gonna move much slower. I want to see a slightly smaller one. Yeah, that one's moving faster. There we go. So this feels good. This feels good. And notice how each asteroid has a different sprite, different size, obviously. Different rotation. So even these two have the same sprite, but they're rotated a little bit differently, right? So just kind of adding some randomness to this to make it feel a little bit more natural, and make each asteroid feel a little bit unique compared to the others. Now I would say that is pretty good. We can always tweak this further if needed, but this is working fairly well. The asteroids are coming in from the outside of the screen. They're going towards me in the middle. And then my job will be to shoot these, and we can check for collision. Oh, and I can actually shoot them, and the collision is being detected, although we need to actually break the asteroids in half, or destroy the asteroids entirely when you shoot them. So we'll definitely start handling that next. All right, let's actually have the asteroids split into multiple pieces when they get shot by a bullet. Or for some asteroids, if they're already pretty small, then they'll get destroyed entirely. But we need to really handle that collision that happens between the bullet and the asteroids. So let's go ahead and open up our asteroid script. And first we want to add a function in here called onCollisionEnter2D. And there's one parameter here, which is collision2D. We'll call that collision. And I think, didn't we add this already? Yeah, we already added this, for example, to our bullet. And for our bullet, as soon as the bullet collides with anything, it gets destroyed. So for our asteroid can collide with multiple things. It can collide with a bullet, it can collide with a player, it can collide, right? So we can't just assume that it should split in half when it collides with anything. We need to specifically know if the thing it's colliding with is a bullet. And so what we can do to check that is say if collision, so this parameter here, it has all the information we need to know of the collision that occurred, the objects that were involved in it, and so on. So we can say if collision.gameObject.tag, this is going to be the game object you're colliding with. If the tag of this bullet, or of this game object, is the bullet, then we can do something, right? But before we do anything, let's make sure we set the tag of the bullet. So if we go to our bullet prefab, we have a bullet layer, but that's usually used more for physics related stuff. Our tag here can be used for really any of our logic, like any game logic. So we can add a new tag. Let's go here. Go to, tags, list is empty. Let's call one, add one called bullet. And there we go, we have bullet. Let's go back to our bullet prefab and set our tag to be bullet. So now every one of our bullets will be tagged with this tag called bullet. And we can check for that tag in our code here. And so when our asteroid collides with a game object, we verify that that object is a bullet. And if it is a bullet, well, then we can do something. So for large enough asteroids, we want to split it into multiple pieces. But we only want to split it into multiple pieces if the asteroid is large enough. And one way we can do this is by saying if the size of our asteroid, if you were to split it in two, so if you took its current size and you divided that by 2, if each of those new sizes then is bigger than your minimum size, well then that means that asteroid is big enough where it can split into multiple pieces. So for example, let's say our size is 1.2. If you were to split that into 2, each of the new asteroids would then have a size of 0.6, which is within our appropriate range that we specified. So that would be good. Now let's say the size is maybe 0.8. If you split that into 2, each new asteroid would be 0.4, which is below our minimum size. So that means that asteroid is already small and is too small where it wouldn't split into 2. Instead, it would just get destroyed entirely. So we can do that. We can say if this.size divided by 2, or I usually like to say multiply by half, is greater than or equal to whatever our minimum size is, well then that means yes, we can definitely split that object into multiple pieces. And so we'll add another function called say create split, which is going to create like one half of the asteroid. So we'll call this twice, right? So we're creating 2 splits. We cut our asteroid in half, it creates 2 splits. So when we create a split, it can actually spawn a new asteroid in place. Now, if that doesn't happen, well, actually, regardless of that happening, we for sure want to destroy our current asteroid. Our current asteroid is going to get destroyed no matter what, because the 2 new ones that get formed are going to just be brand new asteroids entirely. So this current asteroid will get destroyed regardless. When it comes to creating our splits here now, we're going to need to instantiate a new asteroid, of course, and maybe we'll call this half. So it's like half of, it's half of our new asteroid, or half of the, previous asteroid. So we'll say instantiate, we're going to copy this, right? So the object we're copying is our current asteroid. And then the position here will be essentially the same position as our current one, although we want to maybe do a little bit of randomness. That way the two new asteroids don't spawn directly inside of each other, and maybe there's a slight offset to them. But more or less, our position is going to be our current position. But let's go ahead and offset that by a little bit. So we'll say our new position is our current position, but then we'll increase that or offset that by some random amount. And we can say maybe inside unit circle times 0.5. So that's going to offset our new asteroid in a circle, in any direction in a circle, but only by like half of a unit, which is only a small amount. But that should be enough to make it feel like those two new asteroids that are forming from the larger one don't spawn like literally exactly at the same exact point. Like there'll be some variance there that'll make it feel a little bit more natural. And then for the rotation is just, it doesn't really matter, but we'll just match whatever our current one is. And then the other thing I want to do is just set the half. So we set the size of our new asteroid to be whatever our current size is times half, right? So or divide by 2 is another way you could write that. And then from here, we want to set a new trajectory for our asteroid. So we could say half.set trajectory. And the direction here, honestly, the direction doesn't really matter. It can be completely random at this point. Since it's getting destroyed in the middle of the scene, it doesn't matter which direction it goes. It just needs to go anywhere out, right? Which really, it just doesn't matter. So as long as we just say random, inside unit circle, or we say normalized, which is going to give it a trajectory. We want to normalize it so it always has the same, magnitude, or like the same speed, or not speed, that's maybe not the right way to phrase that, but we don't want it to be half the magnitude, otherwise it's going to start to affect like its speed and everything. So want to make sure that's all normalized. It's basically just pick a direction. So inside unit circle normalized, and yeah, it's going to pick a random direction to start traversing on, which is nice. And once again, when we set trajectory, we wrote this function earlier, but speed will be multiplied into that. So we pass in a direction and the speed will already be multiplied into that. So that's why we want to normalize that. Cool. And I think that's kind of it. I don't know that we need to do anything else. So to recap here, we check for collision, specifically check for collision on a bullet between the asteroid. And then we try to split that asteroid into multiple pieces only if the size of it is large enough such that we can actually cut it into half. If that's the case, we create 2 new asteroids, instantiate 2 new asteroids. They're going to have the same initial position of our current asteroid, but with a slight offset just to make it feel a little bit more natural. We cut the size in half, and then we give it a random new trajectory. Any direction, it doesn't really matter. And there we go. And then our new asteroid, or our previous asteroid, gets destroyed regardless. So let's go ahead and test this out and see what happens. Let's wait for the asteroids to start coming in. There's one, so let's go ahead and destroy that. There we go, it got set. Nice. Yep. And so notice how some of them just get destroyed instantly, where others don't. And there we go. Well, it feels good. Now, one thing is they feel pretty slow actually. When they break apart, they feel really, really slow, to be honest. And I feel like their speed should maybe be... The speed is 5, which is pretty low, but we changed that because they were spawning in way too quickly earlier. So we can always just multiply this. If I know, so speed is already being factored into this, into our direction there. But if we want, we can always multiply this more. So let's just say we have whatever the speed is, and then that's going to get further multiplied later on. But let's just test that out and see if it's too much or too little or whatever. But we can also once again play around with that if we need to. All right, yeah, that felt way better. That felt a lot more natural. So we break that one. Yep, that feels much better. Okay, awesome. So that feels good. So now I can actually pretty much play the game. At this point, we're getting close to finishing. All we really have left to do is check for collision on the player now and make sure the player actually dies. And then we can handle things like the number of lives you have. We can handle scoring, do some UI stuff. But for the most part, we have the basis of our game working here. Now let's handle the collision between our player and the asteroids. So let's go ahead and open up our player script. And let's add the same function we've been adding in some of our others, which is on collision, enter 2D. And the one parameters, collision 2D, call that collision. So here we can check, kind of like we did for our asteroid. When the asteroid collided with a bullet, we did something. In our case, we want to do essentially the same thing, but instead of the bullet, when the player collides with an asteroid. Now we haven't yet added this tag, so let's go ahead and do that real quick. Go ahead and go to our Asteroid Prefab. Let's go to tags. We can add tag. Click the plus button. Add a new one. Let's call that asteroid. Let's reselect our prefab and change the tag to asteroid. And so now all of our asteroids will have that tag, and so we can properly check if that's the correct object we're colliding with. If it is the correct object we're colliding with, well, we need to, the player dies basically. And then the player will respawn. And we can keep track of lives and stuff, but for now we're going to just focus on the player is going to die, and then they'll respawn after a few seconds. So when the player dies, there's a few things that need to happen. One, we need to turn off, we need to stop all the movement of the player. So we can say rigid body velocity equals 0 to stop movement. Also, we need to stop rotation, so that's going to be angular velocity. And set that to 0. Oh, this is not a vector. It's just a simple float. Set that to 0. And then we also want to turn off our game object entirely. So set active false. This is going to stop all of the components. It's going to turn off the entire game object entirely. So it's not going to render anything. There's not going to be any physics simulating. The script's not going to run. Nothing's going to be happening with our player. Until the player respawns, then it'll get reactivated. It'll get set back to true. Now, what we will end up doing is we're going to use this invoke function, which you might remember from our asteroid spawner. We did invoke repeating. We're going to do something similar. We don't need to do it repeatedly, but we're just going to invoke a certain method after some time. So let's say the method will be respawn, and the time will be whatever the respawn, however long we want it to take to respawn, maybe 3 seconds. Now the problem is we can't call this here because we're turning off our game object. We can't invoke anything on a game object that's turned off. So we need to do this somewhere else. And this is where something like a game manager might come into play. Right, so we might want to have a new script for our game manager, The game manager is gonna kind of keep track of the overall state of the game. So things like score, lives, the state of the player, whether they're dead or alive, or you know, things like that. That's the kind of stuff a game manager might be useful for. So in here, the game manager might keep a reference to the player, and then there might be a function such as the player will inform the game manager that they died, right? So say player died, and when that happens, we might want to change the score. We might want to decrease the amount of lives, or maybe not score, but lives. So let's say we have lives here. Maybe initially you have 3 lives, right? So we can say when the player dies, where your lives becomes decreased, becomes decremented. And then also we can invoke the respawn function. So we can add a respawn function here. You can say respawn. And then when the player respawns, we just go to our player game object and we set it back to be active true. So invoke name of respawn. And we want to invoke this after, let's say, you know, whatever our respawn rate is, or respawn time, which is maybe 3 seconds. And respawn time, right? So we're going to invoke respawn after some delay, which is our respawn time. And when we do respawn, we set our game object back on. We also want to reset our position to 0. So puts the player back at the center of the board, which is good. And let's see, lives, yeah, gets decremented. At some point, we're going to want to handle our game over. So we can say if this.lives, you know, is less than or equal to 0, then we can do some kind of game over. We don't have that yet. We won't actually handle that quite yet, but later on we can add our game over, right? And then, yeah, we can handle our game over. So we don't want to respawn the player if you have a game over. So only respawn the player if your lives is not 0 or greater than 0. And that's good. Okay, so player dies. We decrement lives. We check how many lives you have left. If you have none, then game over. Otherwise, we'll respawn the player after a certain amount of time. When the player respawns, we reset the position to 0. We turn the game object back on. And then one thing we're going to want to do is, well, we're never actually informing the game manager that the player died. So we need to do that here. Now, to do that, we need to get a reference to the game manager. And there's a few different ways we can do this. I'm going to actually do it the bad way. So I'm going to use, this is the bad way of doing it, but I'm going to do it for simplicity of the tutorial, because I want to keep the code fairly straightforward and not dive into anything too advanced. So I'm going to use a function called find object of type. And here I can find object of type game manager. And this will return me a reference to the game manager, assuming it exists in our scene. Oh, you know, I don't even need to store that in a variable. I can just say game manager.player. And so let me explain why this is bad. First of all, so this function here is really slow. It's very costly to use this function. And so very often you'll see new developers use this function all over the place. And it's going to, and a lot of times it starts to degrade the performance of their game. Now, it's really, really bad to use this function inside of an update, inside of any kind of update, because these are happening very, very, very frequently. And so if you're calling some very expensive function very frequently, well, that's what's going to tank your performance. Now, in our case, although this is a bad function to use because it has pretty severe performance implications, it's only going to be happening every, it only happens when you collide with an asteroid, and then it's only happening once until you respawn, and then that one thing happens again. So for our cases, it's really not going to degrade performance whatsoever, but it's still not necessarily a good, there are better ways you can handle this. There are better ways you can establish a reference, a global reference to your game manager without having to use this method. But once again, I'm not going to go into that for this tutorial because it's going to sort of complicate things. That's maybe not the right way to describe it, but I just want to kind of keep everything a little bit simple for this tutorial, since this is still a fairly beginner, maybe intermediate level tutorial. But maybe eventually we can revisit this and I can show you better ways to do that. So find object of type game manager and inform the game manager that the player died. Okay, let's go ahead and test this out. Let's run this. Oh, one thing we didn't do. So our game manager does not exist in the scene yet. And so it would have tried to find it. It didn't exist. And then that would have caused a crash because I wasn't doing any kind of error handling. And also, like, another reason why that function is bad is because it has to look through every game object in your scene and then every component as well until it finds the right one. And that can be quite a lot at times. But let's create our object game manager. Let's go ahead and drag that on. Let's make sure we have a reference to our player established. Our respawn time is 3. Our lives is 3. And let's go ahead and run this. Let's just purposely crash into the first asteroid we see. There it is. Let's go ahead and crash into you. Boom. So the player ship disappeared. Our lives got decremented to 2. And you can see over here my object is grayed out because it's disabled, and you can see the checkbox there is disabled. So let's go ahead and see that I respawn now. There we go. I respawn. I can move around again and everything's working well. Let's just die again. Now, one problem I can see already happening here is what happens if, for example, you respawn. Well, now in this case, I'm out of lives, so I'm not going to respawn. But let's say you respawn and you respawn directly into another asteroid. That would be kind of unfair, right? You respawn after 3 seconds, and it just happens to be that there's an asteroid already kind of right there, and so you just instantly die again. That would kind of suck, and so that's something we probably should handle. So to prevent the player from instantly dying when they respawn, what we can do is turn off all collisions entirely on our player for a couple seconds, which will give them enough time to move around outside of any harm that might be immediately on top of them. And that should help out a little bit. So we can turn off all of our collisions. It's not as simple as just turning off our box collider though. Instead, what we can do is we can use those physics layers and that collision matrix to turn off all layers. So we can actually temporarily change the layer of our player to a different one. So let's go ahead and add a new layer, and I'm just going to call this ignore collisions. All right. I'll put a space in there. It doesn't actually matter, but let's put a space in there. And so we want, by default, will be set to player, but we're going to programmatically change that to be ignore collisions. But in our physics 2D collision matrix here, for ignore collisions, we can just turn off everything, right? So if the layer is set to ignore collisions, then nothing is going to collide with that, right? So just turn off everything. And now in our script here, we can say when the player is respawned, then we want to change its layer to that. And then after a couple seconds, it will get set back to the normal layer, which is player, right? So one way we can check for when you respawn is, I mean, there's this function that exists, which is fine. So actually, yeah, we could just do it here. Why don't we just do it here? Another way you could do it is potentially in an on enable. So Unity has functions called on enable and on disable, for example. And this might be another place you would maybe do that at. It honestly, for our cases here, probably doesn't matter too much. But since we already have our respawn, I'm just going to do it here. But in theory, it might actually be better to do it on enable because that might cover more cases. But once again, it probably doesn't matter too much for this game. So this .player.layer, or this .player.transform.layer. No, what is this? Player.gameObject.layer. There we go. And then we can say layer mask name to layer. So it's just a way to set the layer given a certain name here, and we call this ignore collisions. All right. So when the respawn, we change the layer to be ignore collisions, which is going to prevent anything from colliding with us whatsoever. And from here, after a few seconds, we should turn that back on. All right. So we can say turn on collisions. And let's say that after this.player.gameObject or this.player.invoke. So we're going to invoke some function called turn on collisions. Let's say, I don't know, after 2 seconds, 3 seconds, we'll give them 3 seconds. We'll give them a 3-second invulnerability before they have to that 3 seconds is plenty of time for them to find a safe spot. So at this point, all we do is set our layer back to what it should be. So layer mask.name to layer, and our normal layer for the player is just called player. All right, so when the player respawns, we change the layer to be ignore collisions, and then after 3 seconds or however long we want to wait, those collisions will be turned back on. And we can even make this a variable here. So we could say, I don't know, we could call this like respawn invulnerability. Invulnerability time is maybe 3 seconds. It's kind of a long name, but whatever. Respawn invulnerability time. That way we can change that in the editor if we would like to. And let's go ahead and test that out. And actually, I already realized now, we probably shouldn't turn off all collisions because then it would allow the player to leave the boundaries of the level. So we probably don't want that. We really should just turn off collisions with asteroids. That's really all we care about. As long as asteroids is checked, but we don't want to let the player leave the game area. So we want to make sure boundaries is still turned on. So maybe ignore collisions might not be the best name for that, but once again, this is a pretty simple game, so we don't have to make things too complicated. So let's purposely die and respawn. And I'm going to try to instantly crash. Oh, this will actually work perfect. Oh, I barely missed me. I was going to try to instantly crash into a... Oh, yeah. Actually, I was already still invulnerable. Oh, so it's actually not working. I'm still invulnerable. And I actually got an error here. Player that turned on collisions couldn't be called. And that is because... I think it's because I'm invoking this on the player, and so it's expecting this function to exist on the player. Rather, I need to invoke this on our game object here since our function exists, or on our game manager since our function exists on the game manager. So that, I believe, should fix the issue. Let's try one more time. There we go. I'm going to let this kill me. And then I'm going to try to run into another asteroid immediately when I respawn. I just missed it. No. Let's try again. Let's crash into you. Let's respawn. And let's... Yep. So there we go. I was able to travel directly through that asteroid. So... This is all just to prevent a situation where when you respawn, you just end up instantly dying because an asteroid happens to be right there And so it gives you a little bit of invulnerability when you respawn, so you can kind of get to a safe place. And so that's it for that. One thing we can do to make our game feel a little bit better is add a simple particle effect anytime the player shoots an asteroid. So when the asteroid explodes, there'll be a little exploding particle effect. We can also use that same particle effect for when the player dies. So let's go ahead and create a particle effect. Let's right click in our hierarchy, go to Effects and Particle System. And I'm going to call this Explosion. And so by default, you can kind of see what's showing up, which is not at all what we want it to look like. So let's go ahead and change a bunch of properties here to get this to look more like what we want. So duration here, let's just set that to 1. The duration just needs to be long enough for the entire effect to happen. So 1 second will be plenty. We don't want it to loop though. It's just going to be a one-time thing. And we'll tell it to play when we want it to play. So it doesn't need to loop over and over again. Let's see what else. Our lifetime here is going to be the lifetime of the particles themselves. So let's say 0.5. They don't need to be very long. So 0.5 should be plenty. And our speed as well is a little bit too fast. So let's reduce that to just maybe 1. And if they feel very slow, but that's also because the particles themselves are way too big. So let's change our start size to be something like 0.05, really much smaller. So that feels pretty good. Now we want to change the way in which these emit and the shape that they spawn in. So the emission here, we don't really want it to be something that emits the particles over time. We just want an initial burst. Right, so we can set the rate over time to 0, but we can add a burst here. So we can say plus button. It's going to burst at time 0. So that means as soon as the particle effect is played, it will do this burst. And it has a probability of 1, meaning it's 100% going to happen every time. And let's say it bursts 10 particles. Right, so that feels better. It bursts 10 particles initially when the particle effect is played. Now the shape here is going to be the big one though. We want to change the shape from a cone to a circle. Now that does not look like a circle, and that's because we need to reset our transform up here. So let's go ahead and reset that, make sure everything's the default values. And there's our circle. So it's going to spawn our particles anywhere inside the circle, which is not quite what we want. We really want them to all start at the very center and then burst outwards, which they are bursting outwards. They just don't start in the center. So we can change the radius of the circle to basically be 0. Now it technically can't be 0, but it's going to be a small enough number where you don't even notice. And now it looks good, where it just kind of bursts outwards from the center point. And a couple little small things we can do to make this feel a little bit better. Let's add a color over lifetime. Let's turn that on. And we just want to fade out the particles as they go away. They don't just like instantly disappear. They'll slightly fade out. So what I'm going to do is for the first 50% of its lifetime, it'll be fully alpha. Everything's good. But then for the last 50%, it's going to start to fade out. Right. So at 50%, it's still at 100% alpha. But then at the very end, it gets set to 0. So you can see over time, it's fully there, and then all of a sudden starts fading out as it reaches its end. And then lastly, this one's really hard to see from here. It'll look a little bit better once we can actually see it in the game, but the default particle that Unity uses doesn't really fit the style of our game. So we might want to change the material here under the renderer and just use the default sprite, right? Which is going to make this feel more like a little pixel. And you actually can kind of see the difference here. But yeah, they'll feel like little pixels rather than whatever the default particle Unity uses is. So there we go. There's our little tiny simple explosion particle effect with just a few, changing a few properties. Oh, you know what? There's a couple things I missed though. So our plan awake, we're going to turn that off because we're going to programmatically tell this to play. And so we don't want it to play automatically. We will tell it when to play. And the other thing is we might want to change the simulation space to world space just to make sure the particles are being simulated in the world and not relative to some other game object that it might be parented to. So but that's it. That is our particle effect. Now we just need to tell this particle effect to play anytime something happens, such as an asteroid being destroyed. Now, to do that, we need to reference our particle effect and tell it to play. And we could reference it in our asteroid script. And then in our asteroid script, whenever we collide with a bullet, we could have it play the effect. The problem with doing it in here is that we won't be able to establish a reference to our explosion, because our explosion only exists in our scene, but our asteroid exists as an asset. And so you can't create references to objects that are in, like, I can't reference an object that exists in this scene in this prefab. So what I am going to do is establish a reference to the explosion in my game manager, and I'll let my game manager handle all of that. So here in our game manager, we can add our particle system is what we're going to reference, and we'll call this explosion. And so, for example, when the player dies, this is one of the places we want to play our explosion. So we can say this.explosion.play. .play. And also we want to change the position of our explosion to be the same position as our player. That way it plays the effect at the right location. So yeah, this.player.transform.position. So that's one of the places where we want to do this. The other place is when an asteroid is destroyed. So we don't currently have that hooked up yet. So we have when the player dies, and then we're heading respawning. We also need to have when an asteroid is destroyed. Asteroid destroyed. And the reason why this makes sense to be here is because this is also where we would do something like scoring. So I guess while we're at it, we can start to add scoring. So we can keep track of score. Initially it's 0. And when an asteroid is destroyed, we can increase our score by some amount. But let me revisit that. Let's finish the particle explosion first. So really it's the same 2 lines of code, but this time we want to change the position, not to be the position of the player, but to be the position of whatever asteroid is being destroyed. Now, how do we know which asteroid is being destroyed? Well, we can pass that in as a parameter to this function, right? So we can pass in the asteroid that's being destroyed, and then we can use that to change to set the position of our explosion and play that. Now we just need to call this function, just like we did for when the player died. We need to call that function. So if you remember earlier, we were using this, which I kind of, I explained how this is actually not a good way to do this. And so we're going to do the same thing again. Just keep in mind, this is not the best way to do this, but I don't want to, I want to keep the code here simple enough for this tutorial, and the better way to do this, I feel like, is slightly more advanced, and I don't think it belongs in this tutorial. So find object of type, game manager, and we can say asteroid destroyed. And then, yep, we have to pass in the asteroid being destroyed, which is just this. And there we go. Yep, so when the asteroid is destroyed, we'll play our explosion effect. We can add a to-do here for score, increase score. But let's go ahead and test our explosion, and then we'll come back to the scoring. Okay, so we have our game manager, our explosion there. Let's drag a reference there. And so now programmatically, whenever those 2 events happen, either an asteroid is destroyed or the player dies, we should see that explosion happen if done correctly. Wait for our asteroid to come in. Let's go ahead and start destroying some of these. There we go. There's a little explosion. Nice. So it feels good. There we go. Nice. Now let's test it out when I crash. So I crash, boom. Oh, that feels good. So I crash, and I sort of instantly disappear because we're turning off the player, but it feels right because then you see this little explosion happen. So it's like my ship just explodes, and it just makes sense. It feels like what it should. Boom, explode. So with a single particle effect, we're able to you know, add a lot of polish and a little bit of detail to the game, and we're able to reuse that one effect for multiple different things. So there we go. Let's go ahead and revisit our scoring. Since we had started to implement that, let's go ahead and finish that off. So in our game manager, we added our function for when an asteroid is destroyed, so we can play our explosion, but we also want to increase our score here. And we did create our variable for our score, which initially has a value of 0. So to increase our score, really it should be, we could just say, you know, every time you destroy an asteroid, your score increases by 1. But I think it would be better to increase our score based on the size of the asteroid, right? So different size asteroids have a different score associated with them. And I would actually say that the smaller the asteroid, the more points you get, because the smaller asteroids are harder to hit, and therefore you should be rewarded more for them. So we can actually check the size of our asteroid because we have a reference to the asteroid being destroyed, and that asteroid has the size property. So we can actually check and say, okay, based upon that size, you know, change the score by this much. Now we could do some mathematical function here to determine that. But once again, for simplicity, I'm just going to say there are 3 tiers of scoring. There's basically small, medium, and large asteroids, and one will be worth 25 points, 50 points, and maybe, you know, 100 points, right? And so let's say if the asteroid size is less than, what was our minimum size? Was 0.5. Okay, so let's say maybe if it's less than 7.5, then maybe your score increases by 100 points, because that would be the smallest. If it's not that, and say maybe less than 1, let me check. So 1 is kind of the middle point. Yeah, let's do, I don't know, 1. Then our score is increased by 50 points. And why does, oh, our score is an integer here, so let's not make these floats. Let's just do that. I also want to do that. Okay, and then if it's not either of those, then we can say our score is increased by 25 points as kind of our default. And so, you know, you can play around with the specific numbers here. It would probably be better to figure out a formula, some mathematical formula for determining the score based upon size. But once again, for simplicity, this should work perfectly fine. And we can see our score increase as we play the game. So let's go ahead and try it out. So this looks like a small one, so let's check that we get 100 points for this. Yep, so we got 100. So these are all small ones, it looks like. So yep, 200. Let's try to find a medium one now. And I'm just getting all the small. I'm getting all the small ones. Okay, this might be medium. It might be large. Let's see. So that was 425. So that was considered large. And then that was broken up into a small one. So that's another large. Yeah, so it seems like the range there is maybe not quite right. Maybe this should be, you know, 1.25 or, you know, something like that is a little bit better. That way our range would be, I mean, in total, our range goes from 0.5 to 1.5. So there's a total delta there of 1. And then if we want to bucket that into 3 different things, then there should be roughly 0.33 between each. So maybe 0.5 to 0.8 is small, or we'll keep that at 7.5. And then maybe from 7.5 to 1.2 is the medium, and then from 1.2 to 1.5 would be the largest. So yeah, that, I feel like that breaks it apart a little bit better. But regardless, doesn't necessarily matter. You can tweak tweak those numbers to get it to feel right. It's all just kind of your preference at this point. But there we've got our basic scoring and everything. At this point, we've pretty much covered everything we need to cover for our game of Asteroids here. The only thing we didn't do yet is our game over state. Now, we're not going to really do a full-on proper game over. Really, all we're going to do for the sake of this is reset a couple of variables and respawn the player just like we normally would. So let's say our lives here needs to get reset back to 3 as our initial, and our score should get reset back to 0. And then from there, we're just going to respawn the player just like we were before. And that's it. Normally speaking, you would do a lot more for a game over. So for example, you would most likely actually have some kind of UI menu that says game over, and maybe it says something about, you know, press X to play again, or press whatever to play again. But just for the sake of time and the simplicity of this tutorial, I'm not going to dive into any of the UI just because it would eat up probably, honestly, another 20 to 30 minutes of just kind of, you know, just creating the UI. Not even really scripting anything, just creating the UI could take some time. So we will not do that here. But let's go ahead and just test out that this still works as we coded it. So our lives is 2, our score is 725. I want to just make sure that once our lives hit 0, it should all reset. So let me just go ahead and die. So now our lives is 1. Let's die one more time. There we go. Our lives is now 3. Well, yeah, it gets reset to 3, and our score is now 0 again. So there we go. It resets. The game kind of just automatically starts over. But if you're curious about what the UI of this game could look like and how to do that, and what the code would be, what the game objects and all their properties would be, the project on GitHub that I've been referencing a couple times, or that I've mentioned a couple times, that project actually has the full-on UI and everything. I appreciate you taking the time to learn how to make the game Asteroids with me. If you feel like you learned a thing or two, then give the video a like to let me know I did a good job, and subscribe to the channel for more tutorials just like this one. Thank you for watching. See you in the next one.